and one or two research area which involves the deep learning and as well as the machine learning. That's what the content of this is. So this is a simple a roadmap when a designer is going to build a machine learning system. First one is that when we look at a research paper, they will use a data set. So that involves a feature which is already extracted it. So when we are going to extract that one the feature on our own, that kind of a feature it is called as a raw data set, or the feature which are extracted by a designer on its own. And accumulation of a data or collection of an extracted data is nothing but a raw data. To build it when the model, to train the model, it depends upon that one model which we are going to train. The label is also associated. I mean to say that when whatever the data is extracted by a designer, for that data a labeling is required. Depends upon application, label is dependent. So once that label of the labeling of the data is completed, next we cannot train that model as it is. I mean to say a data is extracted and the data is collected and the data is labeled. After the data is labeled, the data cannot be used to train the model as it is. Why that data cannot be used directly to train the model? What is the drawback of it? Data which is extracted by the designer or the data which is available in the internet in a raw form, it may have a kind of a inconsistency and incompleteness and a noise present in the data. So due to this, a noise present the data or incomplete data or a inconsistency present in the data, a machine learning model so may not be able to understand the relation between that one instance to another instance, another instance to another instance, another instance to another instance. So in order to make that one the model to learn properly in the sense to achieve that one expected performance ability of the trained model, first and the foremost task is the data need to be a pre-processed. So during the pre-processing, many of that when the steps are involved. Why pre-processing is required is so we need to eliminate that noisy data present in the data set or the noisy data present in the raw data set. Or if incomplete data is present in the data set, that data need to be removed or it need to be converted into a complete data. Apart from that one, the data is present. I mean that one, there's no a missing value for the data, but the data a consistency may not be there. So in such kind of cases, whether the data need to be deleted or the data need to be converted, it depends upon that application. If you have a sufficient number of an instance to train the model, then there is no harm in deleting one or two instances. I mean to say that when if you are removing such kind of instances, there won't be any problem to train the model when we have a large number of instances in the data set.
ఈ క్వశ్చన్ పేపర్ ఎవరికి వచ్చినాయో ఎలా తెలుస్తుంది బిఎల్స్ ఎవరు పెట్టాలి ఎగ్జామ్స్
Yeah, sorry, please can you mute your mic? Yeah, participant, please mute your mic. Okay. So what is that? What is the meaning of incomplete data? What is the meaning of a noisy data? What is the meaning of an inconsistent data? From this example, you can see that on the data, there is no a value for the a given attribute as a feature. If you take this occupation as an attribute or a feature, there is no value for this. The data is the value for this data is missing. So this kind of a data I can call as that one the missing value or incomplete value for a given a data. First, data need to be scanned to identify any incomplete data exists in the data set or not. If at all, if we come across any incomplete data present in the data set, so we can delete the data or we can make the incomplete data to a complete. It depends upon that one how many number of an instances we already have on the data set which we are having it. If you have a sufficient number of instances in the data set, we can delete it, or otherwise missing value need to be added into that. Different techniques are there. Purpose of this expression is, so we need to pre-process the data. During a pre-processing, so one of the step is to identify that one incomplete data, then you take an appropriate action to make that incomplete into a complete or deleted. Second one is a noisy data. For example, the salary is a minus 10. A salary cannot be a less than a 0 rupees or dollars, whatever it may be. So it should be a greater than 0. If we have such kind of values for a given data, in this case, if I take a salary as an attribute, and the value for an attribute is, it should be a greater than a 0. So 1 rupees or 2 rupees or 3 rupees depends upon that one the data set. So it cannot be a negative salary. So it is a one example of a noisy data. In that case, we need to take an appropriate action during a pre-processing of a data. Another example is age. That is another attribute, or it is a feature. The value for an age, a normally human being lives 100 years, 105, 110. If it is equal to 222, it is a kind of an unexpected the value, or it is a kind of an unconsiderable a value. It is not a realistic value. In that case, a value for that attribute need to be deleted, or it need to be appropriate action need to be taken to that. So inconsistent, what is the meaning of an inconsistent? One example, if you look at age under the date of birth. So if a age and the date of birth 1997, if a person who is born in the year of 1997, age may not be matching with that one the year of birth. So there is an inconsistency. So we need to look whether all the data and the value are consistent or not. If a inconsistency come across, so we need to take an appropriate actions. So these are the a very elementary steps you need to perform during a pre-processing of a data. Apart from that, a one more step it need to be performed during a data pre-processing is, take a data set, whether it's a raw data set or it is pre-processed data set. Scan the data a column by column and check entire column. I mean, for a given feature or attribute, the value of that feature or attribute for the entire column is same. If a example, age is an attribute, is a feature, whatever the number of rows or instances exist in the data set, for all those rows, for attribute age, if a value is a 10, 10, 10, 10, 10, 10, 10, there is no meaning of keeping such kind of a column into the database. In other words, I can say such a feature will not give any information for a model to learn. That is why we need to eliminate it. If any column has the same value, that column need to be deleted. Similarly, you scan a row by row of the data set. You check any row will have a same value for entire row or not. If a value is the same for entire row, then there is no point in keeping such kind of an instance or row in the data set. That need to be deleted. So these are the very elementary step I need to take care during a pre-processing a task by the designer or the data scientist. So when a data set is need to use to train the model, before starting to train the model, these are the steps are very much essential. So once this step is completed, so next step. So what is the next step? Whether these steps are insufficient, still there is a few more step need to be checked. What are the step is, certain attribute or certain feature, the values of the feature or attribute may be a extreme in a range. It means that attribute and the feature values are in a very lengthy range. So, example, a salary may be a 1 rupee. That is the minimum salary, and maximum salary may be that 1 crore rupees. So, it is an unrealistic one. So, the range is a lengthy range or a larger range. So, in order to make use of the data, in order to make use of the data to train the model, first there is a concept, it is called as a normalization. So normalization is nothing but whatever the range of a value exists in the data set, you bring down that extends a range of a value of the data to a predefined range or a certain range. Normally it could be a -1 to 1, whatever the value, the range of the value exists in the data set, you bring or scale down that a larger a range of a value to a small range. One example, it could be a -1 to a 1. Again, it depends upon that application. Always we cannot go for -1 to 1 range. So it could be a 0 to 1. So whatever the range of the value a designer needs, according to the requirement of a designer, a data need to be normalized. And the various again, why the normalization is required? What is the significance of using a normalization? If a value of an attribute is a very extreme range, again it hinders the machine learning model or the learning model to learn properly. So in order to make the model to learn accurately or correctly, so there is a need of applying a normalization if a value of the data is in extreme range. So various normalization techniques are already available. So we can take any one of that and apply onto the data set. And before applying onto the data set, first we need to see what a normalization technique is suitable for our data set. So some of the examples are a min-max normalization. It's a very simple normalization. Take a value, the take that one range of the value, identify that one what is that one the least value in the range, and what is that one highest value in the range. Consider the least value in the range as minimum and the highest is the maximum. Take the value and then you apply this formula, x in the sense that a current value minus x min divided by x max minus a x min. If you look at the denominator, x max minus x min, that means x max is always a higher than an x min. The denominator will never be a 0. Only this condition will happen only when we have that one the value in, when we have that one the values in that very larger range, a denominator will never be a 0. In a upper one, if you take that x minus x min depends upon that when the value of an x, the numerator we may get a negative or we may get a positive values. When you're dividing the numerator by denominator, we'll get a very small value. It's a very simple. So using this, one can bring down that on the larger range of a value to a predefined range of values. So another normalization technique is a z-scores. It involves a computation of an average, that is nothing but a mean, whatever the values exist for a given attribute. You for those values, a compute a mean. Again, for the same values, you compute a standard deviation. Then you convert or you apply a z-score normalization technique to each of the values of the attribute or the feature. So value of the attribute or the feature. If a feature or attribute name is age, and the value of that feature we are calling as x, and x minus mu, this is computed for the entire value of the attribute. Similarly, a standard deviation, SD is nothing but a standard deviation. From this, we can scale down any larger the range of a value to a predefined range. So one simple example for a z-score normalization. So these are the four values. For these four values, as z-score normalization need to be applied. I mean z-score need to be completed. For that, you need to compute that one, the mu and as well as the standard deviation. After calculating that one, the mu and the standard deviation, simply we need to apply that one the formula. This formula x minus mu divided by a standard deviation, then it will give a z-score. So like that one, for each of the values of the attribute at the feature, a z-score need to be computed. So finally, we will get a z-score for x. For the x value, the x value is equal to 8. For this, z-score is equal to minus 1.14. And for the next at 10, this is the one. Then these values we can use to train the model. So another the kind of normalization is a decimal scaling. It is a very simple. You take the value and divide it by a 10 or 100 or 1000 or the 10,000, whatever it may be. It depends upon what is the value of the attribute. That is what this is a numerator. You take the value as it is, and the denominator is always, it should be a 10 to the power of 1 or 2 or 3 or 4 or whatever it may be. So based on the value of the numerator or based on the value of an attribute or a feature, we can divide the value of an attribute by a 10 or 100 or 200 or 1000 or like that. In this example, the 2, it's a value of the attribute, we are dividing by 10. So 0.2 and the 0.3. If in another example, this is a 400, so we can divide that divided by 1000. And similarly, another example, in this, the value of an attribute is equal to a 40,000. You can divide by the 10 to the power of 5. We'll get the value. So 0.4 under the 0.31 and 0.2. So in this case, we can bring down that when the value of an attribute to a decimal value. It is also a kind of a normalization. So another one more the concept. This concept is required to see whether our data is positively skewed or negatively skewed or symmetric. So how to view that data as a positively skewed or negatively skewed or asymmetric? In order to see that a data is skewed or not, a three values need to be computed. One is a mean, which we already know, and the mode. So what is the meaning of a mode is, take the data and scan it and identify that one the which a value in the given the data appears more number of a time. So that is nothing but a mode. In this example, a 34 plus, in this example, 34 and 43, 81, 106 and 106 and 115. So 106 and 106 appeared at twice in the data set. It is that one highest in number of times 106 appeared in this data. So for this values, so 106 is the mode. 106 is the mode. Next one is the median. In case of a median, here we need to take a center a value. I mean, so if we take this values, you check number of values present in the given data is odd or even. If it is equal to odd, you take a value which appears at the center. If it is not an odd, you have to take the I mean, we cannot go for that exactly that middle value, middle. So we need to take that one, the equal. That means the right side and the left side of the equal. In this case, a totally 10 values are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5, 5th and the 6th. These two are values are used to compute a median. So 3.7 plus 4.1 divided by 2. So one more observation is, these values are arranged in the ascending order. That's what you need to observe it. So whatever the values are there, these values are arranged in the ascending order. So once we calculated that in the median, using that one median and a mode and a mean, we will be in a position to view whether a data is skewed towards a positive or negative or asymmetric. Okay, this point I'll come back. See, this is what the pictorial representation. So when we see, this is a median and a mean and the mode is all these values are the same. That means a distribution is a normal a distribution. It means that the value is asymmetric. It is not skewed either a positive or a negative. In the the graph, we can see that the values, the mean and the median, are right side to the mode. We can say it is a positively skewed. I mean, the values present is a positively skewed. Whereas in this a third graph, we can see that the mean and the median is towards a left. So that's what we can see. This is a negatively skewed or not. So these are the elementary operation need to perform. So before using available data to train the model. And the previous slide. So what is this slide? So this slide, it is a particularly for a Z score in normalization. So Z score normalization, we will compute a mu and as well as a standard deviation. To compute a Z score, a mean is required and the standard deviation is required. The purpose of using a mu minus sigma plus a mu plus a sigma. So what is the meaning of it? After a computation of a Z score, for all the values present for a given a feature or attribute, we can see that a center is a 0. It means x minus mu divided by a sigma. If a value of an x is same as a mu, x minus mu, value of an x is same as mu, we will get a 0. And next one is a mu a minus a sigma. That means the value of this, I mean left side, mu plus sigma, it means it is right side. The purpose of this is, if you take the range of a value from a mu minus a sigma to a mu plus sigma, whatever the values available in the values available for a feature, 68% of the values covers under this range. If we take the values from this range to this range, a 68% of the values covers in this range. If we take a mu a minus a 2 sigma to a mu plus 2 sigma, a 95% of the values exist, or this range covers a 95% of the values. If we take a mu minus a 3 sigma plus a mu minus 3 sigma to a mu plus a 3 sigma, it covers a 99.7% of the values. So this we can use as a upper threshold or a lower threshold to remove some of the values which exist beyond this range. I have a data set, and for a given attribute or a feature, values are exist, and before using a values to train the model, first we need to see to that which are the values or outlier. So one a simple a method to identify a outlier. Outlier is nothing but the values are abnormal. The values are extremely different. The extremely different values. In order to remove all such kind of an outlier during a pre-processing operation itself, so Z score in normalization can be applied. So by using this one Z score normalization, that is the value mu m minus 3 sigma to a mu plus a 3 sigma. Whatever the values are covers, those values can be retained to train the model, and the rest of the values are so beyond that one a threshold. Those values one can treat as a outlier or anomalous or anomalous values. So those values can be deleted from the data set before training the model. So these are the steps need to be taken care to before using a data set. That data set could be a raw data set or partially a preprocessed data set. So after all of this operation is completed, still some more operation is required further. Further some more operation are required, and what are those operation and how those operation can be performed, and why those operations are essential before training before using a data set to train the deep machine learning based models. So next one is, so after pre-processing the data, I'll be having a data set. In that data set, no in noisy data is present, no incomplete data is present, and no inconsistent data is present, and outliers are already deleted. Next one is, if a data set have a multiple number of features, all those features cannot be used to train the model. I mean to say, do not use a feature exist in the data set to train the model directly. Rather, you apply some standard algorithms or technique to select which are the most a crucial feature which help the model to learn properly or accurately. So if I have a data set, if the data set consists of a 1000 feature, all those a 1000 feature, if we use to train the machine learning model, because of some of the features exist in the data set, model may not be able to learn accurately. In the sense, the predictive a performance of the model or a detection ability of the model may not attain highest a detection accuracy or classification accuracy. In order to make a model to learn accurately, a features and selection is required. During this a feature selection, a prominent features which are required to build the model will be identified. Those features will be used to train the model. So in this discussion, I will explain what is the feature selection, why that feature selection, and how this a feature selection, how to select the features. That's what I am going to explain it. A feature selection is a kind of a process or method or procedure adopted to identify best features out of n features exist in the dataset. That is nothing but a feature a selection. For example, we have a dataset that consists of a 1000 features. Before using all those 1000 features to train the machine learning model, you select which features are highest a crucial which features are a crucial to train the machine learning model. It could be 100 features are crucial, or 150 features are crucial, or 130 features are crucial, or 150 features are crucial. So depends upon that one, the data set depends upon application. So which are those 150 or 130 or 120 or 90 or 50 or X number of most a crucial feature that need to be identified. Identify crucial feature. Out of that one, the feature set, it's nothing but a feature a selection. Why thus a feature selection is required? A feature selection improves a performance or a prediction ability of the machine learning model or classification ability of the um, machine learning model. Second one is to visualize the data for a model selection. Third is it is required to reduce the dimension and remove a noisy data. Apart from that, some other reason why a feature selection is very much important. As it was already mentioned in the previous slide, remove a noisy data. Here, remove a irrelevant data. Irrelevant data is nothing but it's a noisy data. Second one is remove a redundant data. If a feature appears twice in the data set and both the feature have the same values, you remove a one feature. That's a redundant. Similarly, if I have two rows or multiple rows are same, then there's no point in keeping that one the same row multiple times in the data set. We can remove a redundant instance, a redundant row. And next, to increase that one predictive accuracy, that means a classification ability of the model, a detection ability of the model, or okay, to reduce the cost of the data. The meaning of a reduce the cost of the data means if a data set is a very large, it takes a quite amount of a memory, and again it increases the complexity of the model, and the training time also will be increased. So if the data set size is reduced by selecting a crucial features, the process is a faster, consuming a less space, and complexity or computation complexity also get reduced. That's what to reduce the complexity of a resulting a model description. So these are the very element primary reason for applying a feature selection on a data set before training the model. Same thing. What are the advantages of feature selection technique? One is if we have a less number of features, it's easy to debug, and it is easy to understand, easy to build a model, and make a training is a faster. I mean, it make the model to learn quickly, increase the performance of the model. That means a detection ability or classification ability of the model gets improved, and removes irrelevant features or a noisy feature present in the data set. So these are the reason for applying a feature selection technique. One a simple understanding: full a feature set, it consists of so many number of features. Out of these features, irrelevant features need to be identified. To identify that one irrelevant feature or inappropriate feature, a feature selection need to be applied onto that one final the full feature set. After applying a feature selection on a full feature set, it denotes which are a crucial feature and which are a non a crucial feature. After completion of this feature selection, keep only that one crucial or highly important a feature as a final a feature a set. Final feature set is nothing but it's a set of a features are derived from original a feature set by using a feature selection a technique. In other words, a final feature set consists of a feature which will be used to train the model. Why a more number of features cannot be used? There is a very old paper. This paper shows that as the feature sizes keep increases, and accuracy of the model also keeps decreases. That is what it depicts. So this is I mean, whatever that one accuracy they have shown, this is an accuracy shown only for the data set what they have used. The same thing will not be applicable for all application and all a data set. So here they have used that one for 30 feature, they attended an 88% of an accuracy. The same thing will not be applicable for other a data set also. It's completely a data set a dependent. So concept is, as the number of a feature increases, accuracy is keeps reducing it. In order to make a model to achieve a best accuracy, there is a need of a feature selection, which select the most a prominent features. Another example, this is also a demonstrate the same thing. As the number of features are increases, accuracy y axis, accuracy name is not written, but it's an accuracy y axis. The title for the y axis is not printed on the slide. It's an accuracy. Accuracy of the model is decreases as a number of features increases. So that is the reason. So model should not be trained with a more number of a feature. Model need to train only with a prominent feature. That prominent feature identified by using feature selection. Why accuracy is, why does accuracy reduces with a more feature? What is the reason behind it? Simple answer is, if we have a more a feature, there could be a reason that some of the features act as a noisy feature. That could be the reason that as a more number of features are used to train the model, accuracy also will get reduced. How does it depend on the specific choice of a feature? What else it changes if we use a more features? So how do we choose the right feature? So how do we choose the right feature? And for all these questions, simple a solution is apply a feature a selection. Okay. This I already explained. Correlation based a feature ranking. This I'll it's a correlation based a feature ranking. To understand this, I'll take this example. In this, this is one simple example to understand how to select the best a feature. If you look at a feature F1 and F2, F3, F4 indicates feature 1, feature 2 and feature 3 and feature 4. If you look the values of a feature 1, so 04 and the 02 and the 05, all these values belong to a class 1, and the 04 doesn't belong to a class 2. Similarly, a 02 also does not belong to a class 2, whereas a 05 belongs to a class 2. From these two, 07 and 09 and the 04 and the 02. So these two are the unique value which associate with a class 1. Similarly, a 07 and the 09, these are a unique values associated with the class 2. Means these values of this attribute is useful for a model to distinguish whether the given instance is belong to a class 1 or class 2. That is the reason. So this a feature it cannot be eliminated, because the value of the features are unique with respect to class, which helps a model to understand accurately during a learning stage. Similarly, these values also is related to a class 2, which helps a model to learn accurately during training time. If you look at a feature 2, again the same thing, a 06 does not belong here, and a 04 does not belong in a class 2, and a 07 does not belong to a class 2. Similarly, the value of a feature 2 of class 2 does not belong, do not belong and to a class 1. It means this a feature it takes a unique value for a class 1 instances. Similarly, a feature 2 it takes a unique value for a class 2 instances, which makes a model to understand accurately. So that is the reason. So these two features cannot be deleted from the data set. If you look at a feature 3 and the feature 4, under the value of this a feature 3 are a random in nature, it has never given any kind of correlation to a class 1 a class 1 or class 2. Similarly, a feature 3 and a feature 4 will not at all be correlated with either the class 1 or class 2. So these values are random in nature. So because of the random in nature, can we delete these two features directly? Or any other observation we need to make? If we make any other observation, whether that observation will give a unique value for a class 1 or class 2? Yes. So these two features we cannot remove. We have to retain as it is. So we need to analyze on this. So how to analyze it? Again, depends upon the setup. I mean, certain the test need to be performed. Now, if we add these values, the point 4 and the point 6, the 1. Similarly, 1.6 and 0.61 and 1.8 minus 0.8 1. By adding the value of a feature 3 and a feature 4, we got another values, and these values are unique to a class. Similarly, if we are adding these, we got 1.1, and 1.8 minus zero point 0.7, we got 1.1. So this 1.1, 1.1, 1 point is unique to class 2, whereas a 111 it is unique to a class 1. By adding the value of these two feature, we got another feature, sorry, another value, so which we can call as a derived feature. We can give a feature name for this, example f5 or f6 or f7, whatever it may be. So f5 or f6, which is derived from a feature 3 and a feature 4, which helps a model to understand or distinguish so class 1 instances correctly with a class 2 instances. So in this way, so we can derive the values, and we'll see that the derived value will be useful to distinguish a class 1 instance to a class 2 instances or not. If it is so, then we can use it, otherwise we can delete it. So these all that one, that a certain a step of operation it need to perform, so during a feature selection operation. So type of a feature selection. So what are the different types of a feature selection? A feature selection types are classified broadly into three categories. One is a filter based feature selection, and a wrapper based feature selection, and embedded based feature selection. From this and this, we can understand that a filter based feature selection do not involve any kind of a classifier to identify which a feature is a best, which are the features are crucial, and which are the features are non-crucial. In a simple sentence, I can say a filter based feature selection technique do not involve any learning model to ascertain which features are crucial and which features are non-crucial. Whereas in case of a wrapper based, makes use of the makes use of a learning model. In this, they have given a classifier, generic learning model, to name, to label certain feature as a crucial features, and the certain features are a non-crucial feature. Whereas in case of embedded, so embedded also you can see that when there is a classifier, here also there is a classifier. Only the difference between embedded and the wrapper is embedded the feature selection technique, which is a union of a feature space and a hypothesis space. Whereas in case of this This is an outer of the classifier. Hypothesis a space is outside the classifier. Whereas embedded one, hypothesis space union a feature space which gives a best feature. So that is only that then the difference between filter based and wrapper based and embedded feature selection technique. In both wrapper based and embedded based feature selection technique, a learning model is used to uh, name the features as a crucial and a non-crucial. It's a very simple, the same concept. So learning algorithm, it means a machine learning algorithm, and before a training the machine learning algorithm, a best feature need to be identified. So best a feature or a subset of a original features. That's what it is, a full set. From the full set of a feature and subset of a features are derived, and these a subset of a features are a best a feature. To select or identify or ascertain or derive a best a subset of a feature from original feature, from original feature set, a feature selector is applied. This is nothing but a filter based a feature selection. So filter based a feature selection takes a one feature at a time and generates a score to each other feature. At the end, it gives a score for each of the features exist on the dataset. Based on the score, designer or a data scientist can decide so which are the features are a crucial and which are the features are a non-crucial. So once based on the score and the topmost features are selected, those a topmost a feature is treated as a best a subset of a feature, where this subset of best a subset of a feature learning model is trained. Once the model is trained, then performance evaluation of the trained model need to be conducted. To conduct performance evaluation of the trained model, unseen unseen a test input need to be supplied to the trained model. Unseen in the sense the instances which used to train the model, those instances should not be used to train the model. Whatever the instances which used to train the model, those instances should not be used to evaluate the performance of the trained model. Unseen means the new instances or new testing instances which were not a part of training a data set. So based on that one, the prediction based on the output given by the model, one can measure the predictive accuracy or detection ability of the model or classification ability of the model. Okay, this I already covered. So what is the advantage of filter based feature selection technique? It is a simple and simple to apply. What is the drawback of the filter based feature selection? Bec- as I already said, it doesn't involve any learning model to give a score of the feature. That is the one a drawback. Another one is it does not take correlation between a feature to a feature. It will consider only the correlation between a feature to a class, or in other words, correlation between a feature to class is checked, not a correlation between one feature to another feature. That's what the drawback of the filter based feature selection technique. So another the technique is a wrapper based. If you look at that from the previous diagram, in this diagram, see there is no a learning algorithm is used here in case of a filter based feature selection technique. Whereas in case of a wrapper based feature selection technique, it makes use of a learning algorithm to identify which features are crucial or which features are non-crucial. That is, rest of the things are the same. So these all the things which I already explained. In case a filter based feature selection technique, and you apply the filter based feature selection technique, it gives a score for each other feature, and based on the score select that one the topmost feature, and those feature is called as a selected feature, and the selected features you can use to train the model, and then you evaluate the model. Whereas in case of a wrapper based feature selection technique, use an user learning algorithm, then it gives features, and those features used to train the model. So embedded a feature a selection. So embedded a feature selection. So which I already said in a diagram. When I was explaining the diagram, I already explained. It is almost a similar. This is what, yeah, here. So embedded, it is similar to a wrapper based. The difference is the feature space union hypothesis space. That's what it is given. It is a similar to a wrapper approach in the sense a features are specifically selected for a certain learning algorithm. But in this approach, a features are selected during learning process. That is the only the difference between wrapper based and the embedded based. So this is a one kind of a taxonomy of a feature selection. The feature engineering, the feature engineering involves a two-step. One is the feature extraction. After feature extraction, the steps whatever I explained, all those steps will be covered. Which semester? What's your name? You are a CRM. You can take, you can talk to that person in the office. Sandeep is in the office, he will provide the laptop. Fourth floor. You don't know where is the office. Go to office, go straight, go down, stay corridor, go straight, go down, opposite state there than department office, then you can ask. Sunday. Sorry, there was some official call. This a feature engineering involves a feature extraction. After the feature extraction, what are the steps I explained? All those steps need to be applied. So when it comes to that one, the feature selection, supervised and the unsupervised. I think by this time you're already aware of it. So what is that one? The supervised and unsupervised. Under the unsupervised, filter based and wrapper based and hybrid based. Sorry, embedded based. And hybrid based is nothing but a collection of a filter based and other wrapper based. So based if hybrid method of feature selection is a different from embedded one. So hybrid is nothing but collection of a both a filter and other wrapper. Same thing in unsupervised also, a filter based and wrapper based and other hybrid. So it is a different under the filter based, the univariant and the multivariant. It means that one whether we have that one only one feature or whether we have that one multiple feature, that the univariant dataset and the multivariant dataset. Next, extended a taxonomy, so it gives a more information about filter based and wrapper based and hybrid based. It is feature engineering as similar to the previous one, feature extraction, and the next one is a feature selection. In this under feature selection, a supervised feature selection. This is what a supervised a feature selection. Supervised feature selection, it consists of a filter based, embedded based, hybrid based, and wrapper based. That is what is it. The filter based, wrapper based, and hybrid based, and embedded based. Under each category, this is a filter based. So these are the different feature selection algorithm or technique. So information gain and chi-square and the Fisher scores and relief or mutual information. So these are the varieties of a filter based a feature selection under a supervised feature selection technique. So embedded methods, one regularization and a random forest and hybrid, which is a collection of a filter based and a wrapper based. And next, a wrapper based, so forward feature selection and the backward. And this is you come at 12:50. HOD room, not here. Okay. So here, this part I have explained just now, and unsupervised. So this is what the next slide depicts. So, feature engineering and unsupervised feature selection, and next one the filter and wrapper and hybrid base, and these are the different categories of unsupervised feature selection. Next, I'll because of 1 hour completed, I'll be stopping at this feature selection. So before going to that, take that one the next topic, I would like to ask. So any doubts related to the content which I discussed so far? Any doubts? Any questions or any queries? Audience, any questions? Any doubts? No questions. Any questions from audience side?
Yeah, dear participants, if you have any doubts, you can raise. You can unmute your mic.
No, sir.
Okay. Okay. No. Okay. If no doubts, then I'll continue to feature selection technique is a very vast the topic. I'll be stopping here. I'll be explaining other topic. Now it's 11 o'clock. 1 more hour time is there. I'll take you to the next topic. So before so many techniques. Okay, I'll be stopping this and next a topic. This is with respect to um, so one more a topic which so a dimensionality reduction. The dimensionality reduction is different from feature selection. A dimensionality reduction is a sense if I have a dimension of 100 feature, you would like to reduce it to a 50 feature or 60 feature or 70 feature, depends upon the requirement. So dimensionality reduction is nothing but it's a process applied on the data set to reduce the feature size from x number of a feature, sorry, from n number of a feature to a x a number of a feature, and x is lesser than a n. If I have 100 features, how to reduce 100 feature to 50 feature or 70 feature or 30 feature or 40 feature? So various dimensionality reduction techniques are available. So one of the widely used dimensionality reduction technique is principal component analysis. It is used in diverse application, not only in IT related application. It is applied in a various application. Another dimensionality reduction is autoencoder. And the next one is a variational autoencoder. Like that, a techniques already exist, depends upon application. Whichever it is suitable, we can adopt and we can reduce the dimension. And if we apply a principal component, if you want to apply a principal component analysis or PCA, before applying a principal component analysis, some elementary information is required to understand what are those elementary information and how those is useful to apply a principal a component analysis. That's what I'm going to discuss now. Before going to take into a principal component analysis, a very basic information, that is a variance and standard deviation and covariance and the eigenvalue and the eigenvector. So these all the concept need to be understand correctly to apply a principal component to solve or to reduce the dimension. We have that when the set of a values. For this, a set of a values and variance need to be computed. Once the variance is computed and the standard deviation can be computed very easily. To make what is exactly the variance, this is a simple example. To compute a variance, primary requirement is a mu. Compute a mu. This is what the mean. And after computing the mean, take one value at a time, subtract with a mean, square it and add it. That is the nothing but the variance. Finally, we need to divide by n. So this is what the mean. After computation of a mean, take the value, subtract with the mean, square it. Similarly, you take another value, subtract with the mean, square it. Same process I applied for every value present in the data. So mean value present in the data, square it, plus the mean value present in the subtract with the value present is square it. Like that one, whatever the points, whatever the values are present in the data, you compute this. After that one, how many number of points are there in the data, you use that data to divide this value. That is nothing but a variance. So summation x minus x bar is nothing but the mu. Take a value which is present in the data, that is a x, and I indicates ith value, subtract with the mu and square it, keeps adding it. The summation is nothing but adding. Finally, you divide by how many number of data points exist in the given data. That is nothing but a variance. The square root of a variance is nothing but a standard deviation. To first, to calculate a standard deviation, the variance is required. To compute a variance, a mu is required. So once a variance is computed, just apply for a square root, then we will get a standard deviation. So here we need to understand that a standard deviation will not have any a complex value, that is I. So 3 plus I. So because here we will not have any kind of a negative because of the square. So standard deviation will never land up into a negative values. So whatever the negative we are getting here, that will be a removed of because of a square operation. So as a result, always we are getting a variance as a positive value. So because of a positive value of a variance, a standard deviation also will never be a negative. So this is the fundamental concept one need to understand. And how to compute that one, the variance for a two-dimensional data. So these are the points. Let us assume that one, these are the points, and the value corresponding to x-axis, the value correspond to x-axis, the value correspond to x-axis, the value correspond to x-axis is marked here. So this is what that when the value correspond to this point on x-axis. So this is the value on the x-axis, it corresponds to this point. This is the value, it correspond to this. Similarly, the value it correspond to this and value correspond to this. See, whatever the values are present in that one two-dimensional data space, for each of the values, corresponding value exists in the x-axis, you mark it. Similarly, a y-axis, because see this point and this point are lies at the same. So that is what only one point. Similarly, these two are appears on the same y value. That is what only one. So these three also have that one the same y value. That is what only one. And this is a one. This is a one. So after computing that one x and the y value corresponds to each of the point in the 2D plane. Next one is compute the center of this. That is a center, and mark the value corresponding to the center on x-axis and y-axis. Whatever the center is computed for this 2D plane, corresponding value on x-axis and corresponding value on y-axis, you mark it. This is what the corresponding value for this is. This is what the corresponding value for this is. You take this value as a mu for x-axis. You take this value for as a mu for y-axis. Then you compute it. Here, the variance means always is associated with a single variable x, whereas a covariance is always is associated with a two variable. That's what the difference. So whatever that when the formula used to compute the variance for single variable, same thing they have used for a covariance. Only a difference between the variance and the covariance is covariance makes use of a two variable, that is x and y. So xi minus x bar, that is a mu whole square, we are writing into xi minus x bar into xi minus x bar. This is only for a single variable x, whereas covariance is for a two variable xy. One component written is as it is, for the next component that is yi minus y bar. So this is nothing but a covariance. Easy to understand. So only one point is a covariance of x comma x is nothing but a variance of x. If you subtract here, if you substitute x and x bar here, we will get x minus x bar whole square, which is nothing but a variance. Covariance of x comma y is nothing but a covariance of y comma x. Okay. So how to compute this values? From this you can see that, and by seeing this, one can easily understand whether the points in the 2D plane, it is a positive correlation or negative correlation or no correlation at all. We can see this is a positive correlation, and for the positive correlation we have to check these conditions. You can see that simple way I can say that the data points is moved towards a right direction. So all such kind of a data points, I can say all data points are a positive a relation. If you take a negative, that same concept, the data points are moved towards a left a direction, in upward direction. So that is what a negative relation. And third one is a data point is not moved towards either the right side, right upper side, or the left upper side. It is scattered at the center of the 2D plane. So there will not be any relation. So that is what a no relationship. By seeing this, by visualizing that when the data point in a 2D plane, one can be able to understand whether the data is positive relation or the negative relation or no relation. Same thing, we can see this is a negative relation. The data points are moved toward the left upward direction. Positive relation, the data points are moved toward the right upward direction. No relation, a point data points are lies at the center of the 2D plane. Same thing here, you take that one, this is a no relation and a positive a relation, and this is a high positive relation and a perfect a positive a relation. So correlation of x comma y. Similarly, on other side, a low negative relation and the high negative relation and a perfect a negative relation. By seeing the value, we can say that. So what is that one? The correlation, and how this variance and the covariance is useful to compute a principal a components. So principal a component analysis is a dimensionality reduction technique, or I can say it is a popular a dimensionality reduction technique applied in a varieties of area to reduce the dimension of a feature space. How it works? It works based on the principle of covariance. Okay, so before understanding this principal component analysis, so I will give you a simple example which makes understand how principal a component analysis is useful. The same example, if we apply to a machine learning a dimensionality reduction, one can easily correlate it. So before explaining a fundamental, the steps involved in a principal, a component analysis, this is an example which gives a clarity about a principal component analysis. So totally a 18 values are there, 3, totally 18 values are there. So this is a 12. It's not 1, 2. It's a 12. It's a 12. So totally 18 values. 3 plus 3 plus 3 plus 3 plus 3 plus 18 values are. If each value requires 1 byte of memory space to store, so to store all 18 values, it requires 18 bytes. How to reduce the memory space requirement? By using a principal component. So originality of the data remains should be a same, but a data originality of the data remains same, but a memory requirement should be a lesser as compared to a original memory requirement. How to achieve it? The simple way, 1 into 1 to 3 is a 1 to 3. You see that is whether is there any possibility of bringing another set of a value to a similar to a previous one. Yes, I can convert this value in this form, a 3 into 1 to 3. Similarly, a 4, a 2, 6, we can convert into a 2 into 1, 1 to 3. 5, a 10, a 15, we can convert into 1, 2, 3 into 5. Similarly here also. So we can convert it. Now 1, 2, 3, 1, 2, 3, 1, 2, 3 and 1, 2, 3, 1, 2, 3, 1, 2, 3. It is a common for all a 6 set of a values. If we store this a 1, 2, 3 only one time, which consumes as 3 bytes of a data. Next one is this is a constant 1, 2 and 3 and the 4 and the 5 and the 6. 6 constant and the 3 values. Totally a 9 values need to be stored. Each value, if 1 byte is required to store a 9 values, a 9 byte is required, which reduces a 50% of a memory requirement. So this is the way the principal component analysis works. So instead of using that 100 feature, reduce that the dimension of 100 feature to 50 feature or 30 feature or 40 feature or 70 feature, which saves this one space and reduces the complexity. That's what the concept of a principal component analysis. Okay, so this I will after this I will explain. Okay, now I'll come back to this deep learning model. So in case of a machine learning model, a feature selection is important, but feature selection, it depends upon that application data set. It takes its own the time to select the features and apply the algorithm again to train the model, whether the topmost 20 feature is sufficient, whether again another set of a feature need to be added or not. So it is a kind of trial and error method and trial and error method. So what I mean to say, machine learning model, most important the steps involved in the data pre-processing and other the feature selection. The human involvement is required to select the best feature before choosing the training learning model. So once that one feature selection technique is completed, then a model training phase will start. So it consumes a lot of time for a data scientist or that one the human to involve selecting the best feature. Is there any way to model to learn automatically the feature which are distinguishable for a one class of a data to another class of a data? So that is what the deep learning a model is a come into a picture to reduce the burden of selecting that one the prominent feature from the data set or the raw data set. Another way of another model is required, that is nothing but a deep learning model. In case of a deep learning model, there is no a human involvement or a data scientist involvement is required to select the prominent features. Model itself is able to learn require a feature to distinguish a one set of a data to another set of a data. So that is a nothing but a deep learning a based a technique. Simple a definition of a deep learning a based technique. So many models are already available. So we are using only a those model a directly an application. So that is why we can call deep learning is a computer software. That objective is to mimic a brain of a human a being human brain. Deep learning is a software. Primary objective is to develop a software or deep learning model that should work as a human a brain. Second one, it is a subset of a machine learning based on a artificial a neural networks with a representation a learning. So it is called a deep learning because it makes use of a deep a neural network. So what is that one, that neural network? I'll going to explain it. So before going to that one, the further details or elementary information of a deep learning, a deep learning, it could be a supervised. I mean to say that the deep learning can be trained with a labeled a data set, or it could train with unsupervised, so no a label associated with the data set, or it could be semi-supervised. So semi-supervised is nothing but it is combination of a supervised and the unsupervised. In case of an unsupervised, no label is associated with the data. In the sense, no a class label is associated with the a data is nothing but unsupervised. Supervised data set for each instance of the data set is a label, that is a class label. A deep learning algorithm. It is constructed with a multiple layers. Very a elementary information about a deep learning is it consists of input layer, it consists of an output layer, and the layers lies between input layer and output layer called as hidden layers. Normally, a number of layers hidden the number of layers hidden between input layer and output layer is little bit more. It depends upon that when the number of a layer lies between input to the output, we can call whether that it is a deep learning or it is a deep and neural network. And how many number of layers, how many number of hidden layers? So nowhere else there is a hard rule that this should be the hidden number of layers. It is required for all application to achieve a best performance. This is a one a schematic a diagram. It's an input layer and output layer. Between that input and output, so many hidden layers exist, and each circle in the hidden layer, it is called as neurons. and the neurons are connected to each other, and neurons will process and then propagate the input signal. It receives the layer above. The strength of the signal is given the neuron in the next layer. It depends on a weight and activation function. I'll discuss about what is that one, the weight and the bias and activation function. So this is a one picture to represent hidden layer exists between a input layer and output layer, and each hidden layer it consists of a multiple neurons. So this is one a diagram which clearly distinguish between a deep learning and another machine learning. In case of a machine learning, a feature extraction is involved. After extracting the feature, and the data cleaning is involved. After cleaning the data and the feature selection is involved. After performing all these a prerequisite step, then the model is going to train. Whereas in case of a deep learning, so this a feature extraction, data pre-processing, and the feature selection is completely taken care by a deep learning model. So that is feature extraction plus a classification. So this a whole a task is taken care by a deep learning model. Purpose of coming up with or purpose of evaluation of a deep learning is to reduce the burden of a feature extraction and feature selection, which is followed in a machine learning. So that is what that one the major a difference between a machine learning and other deep learning. So automatically the deep learning will be able to learn the feature which are required for a classification purpose, or which are required for giving an output for the input data. Why deep learning is useful? It's already I explained. The existing machine learning or uses a manually designed features. That means the feature selection task is taken care by a data scientist or the user side, often over specified and incomplete, and it takes a long time to design and validate it. So much of the time is involved in selecting the best features and use those selected feature, train the model, see that one expected performance is attained by the model or not. If it is not, again you change the features, train the model, test it. So that's the reason it's a quite a lengthy process or a trial and error method to make the model to learn accurately, and then you validate it. Once we attain to the highest accuracy, you stop it. And learn features are easy to adopt and fast to learn. Whereas in case of a deep learning provides a very flexible and universal and learnable framework for representing the world and visual and linguistic information. It is for both unsupervised and as well as supervised. What exactly the deep learning? So deep learning, I can say what is the deep learning? What exactly the deep learning? I can say a deep learning means using a neural network with several layers of a node between input and as well as output. It's a very a simple a definition of a neural deep learning. Why it is a generally better than other methods on image and speech and a certain other type of a data. It is better because a series of layers between output and input. In the sense, in between that one input layer and output layer, a series of hidden layers exist. Those hidden layers objective is to extract the features and process those extracted features in a series of stage, just like how our brain does. And multi-layer neural network have been around 25 years. What exactly new? What exactly the new? So we have always had a good algorithm for learning with weights in the weights in the network with a one hidden layer. So green neurons shows that hidden layer neuron, or a neurons exist at the hidden layer. So green is identified with hidden layers. Whereas in a conventional method, input layer, that is a circle with a black color, and the circle with a black color, that is an output, only one neuron at the output layer. In between that one, input layer to output layer, and multiple neurons exist, and these are hidden layer neurons. Hidden layer neurons are represented with a green color. Whereas in case of a deep learning, we can see that in between the input layer and the output layer, or in between a neurons of input layer and output layer, so many a hidden layer exist. In each hidden layer, there is a set of neurons. So that is what that one the new things in a deep learning, and these neurons are meant to extract the unique a feature of a input a data. So when whatever that when the feature which are required to classify, and those a feature are extracted by these a set of neurons. It is a simple a single unit. So I've in earlier case, weight and the bias and the activation function, and the various types of an activation function. So one is nothing but a linear activation function, and the sigmoid activation function, and the tan activation function, and ReLU activation function, and the softmax activation functions. It depends upon our requirement. We can use whichever that one activation function it is required to solve our problem. We can use it. And this is a neuron input, I mean x1, and the w1 is nothing but a weight associated to this x1, and w2 means it's a weight associated with this, and the weight associated with x naught. And what is the different types of activation function? That's what I'm going to explain it. A sigmoid activation function. A simple to remember, a sigmoid activation function equation is a 1 divided by 1 plus e to the power of a minus x. And the value of this a sigmoid activation function, it appears the curve like this is. And in most of the deep learning model, if you observe it, it is widely used. A sigmoid activation function is widely used. So this activation function, sigmoid activation function, a transformation, it generates a smooth a range of a value between a 0 and a 1. So another a sigmoid another activation function is a rectified a linear a unit. It is nothing but a ReLU. A simple concept. It gives the maximum value. That's it. It takes the value of x and compare with a 0. So whichever is a maximum, that value will be returned as the final output of a ReLU. So ReLU of x is nothing but a maximum of x comma 0. So between these two, whichever is the maximum, so that will be returned as an output of a ReLU activation a function. And next, a softmax activation function. It is a kind of an activation function and normally used in the output layer for a classification a problem. A softmax activation function it generally is used used at the output layer of a classification a problem. It is similar to sigmoid activation function, with the only difference being output or a normalized to sum up a 1. It is a deep learning, a concept. The deep learning is used to solve a various types of a application. The demonstration of this is it is widely used in varieties of an application. It can be used in a security and a defense, and it can be applied on autonomous machines, and it can be used in media and entertainment, and it can be used in a medical field, and it can be used in a cloud and internet. So deep learning is applied to solve a varieties of a problem. So that is what it is shown here. So in case of a security, if I take a security, a face recognition, so one kind of an biometric authentication, and a video surveillance attendance purpose, we'll take that one the face, and we'll mark the attendance whether the person has come or not, and a satellite imaginary. So these various application we can apply that one the deep learning concept. And the key difference between that one machine learning and the deep learning. So deep learning means it's a subset of a machine learning, and both a type of a learning or a subfield of an artificial intelligence. So deep learning is a subset of a machine learning, and both are a subfield of an artificial intelligence. So there are it's difference between that one the deep learning and the machine learning. As I already said, the human interference, particularly the feature extraction and the feature selection, is not a required in case of a deep learning, whereas in case of a machine learning, the human involvement or human interference is required to extract the feature, select the feature, then you send those selected feature to train the model. So that is a one, the difference. And the second one is a complexity. In case of a deep learning, because a model itself, it need to understand, extract the features and learn the feature and distinguish between one class of a feature to another class of a feature. A complexity wise, the deep learning is a little bit a complex. It is a little bit a complex as compared to a machine learning a model. That is a complexity wise. And second thing is, in case of a deep learning, to train the model accurately, a sufficient a number of training instances are required. Third difference is a complexity, I mean computation power, or computation power or computation resource required to train the deep learning model is a more as compared to a machine learning a model. So this all comes under a complexity. Under algorithmic a difference, so what is the algorithmic difference between a machine learning and other deep learning? And machine learnings are detected by a data scientist and analyst, while a machine deep learning algorithms are mainly a self-depicted. And the data representation, generally, this machine learning algorithm typically require a structured data, where a deep learning rely on the layers of artificial neural network. And the scalability, and machine learning is not well suited for solving a complex problem with a larger data set. And the hardware, because of a computations are extensive, hardware requirement for machine learning based classifier or machine learning based learning model requires a less amount of an hardware as compared to deep learning. So deep learning model generally requires a gpus. And the time wise a difference, because it takes a deep learning model, and normally it takes a quite a large amount of a time to train the model as compared to a machine learning model. And the approach, a machine learning tend to require the structured data and useful a traditional algorithm like a linear regression, whereas a deep learning employs the neural network, and it builds to accommodate a large volume of unstructured data and application. So machine learning also is used to solve a various real world applications, and deep learning is also used to apply in so varieties of an application. It is another a pictorial representation difference between machine learning with deep learning. This point I already explained. Describe your data with the features a computer can understand, and a learning algorithm, that means after selecting the features. So these all the very basic information difference between machine learning and the deep learning. So I will take one simple example of a simple real world application which solved using a deep learning a model. Before going to that explanation of real world application, so just if anybody having any doubts, any queries, please let me know. I will clarify your doubts. Now I will go to take another one or two the real world examples, a real world application which are solved using a deep learning models. Any question from audience side? Any doubts?
Sir, no doubts.
Sir, sir, kindly can you open the reference page also, sir, so that we can view it? Thank you.
Okay. So next one is the real world a problem. This currently my PhD student is working on this. I will explain you that what are the challenges are existing in this field and how the deep learning model is useful to solve that one the real world a problem. So this is nothing but I mean whatever I am explaining here. This is a plant, a disease, a detection. So this is one essential area which is required in today's scenario. So moment when we have any kind of a headache or the fever or unusual health issues, we will go and we'll consult a doctor and we'll take a prescription and then we'll follow the prescription. Then in a 1 day or 2 days of a time, we'll recover it. If any extra severe things, the surgery will be done and then they will take a rest and then they will recover it. What about such kind of things has happened to a plants? Who will be there to take care of the plants? If we are not concentrating on the plant disease, and tomorrow will not have a food. If we do not have a food, the survival of human being is a question mark. So whole our human beings is purely depends upon the food which we got from the crop, and which it depends upon the plants and the plant and the tree, whatever it may be, fruits, and the fruits also essential, and the food grains also essential, and the plants also essential for getting that oxygen. So it is very much essential. If any crop get diseased, hardly a few agriculture scientists or agriculture officers available, and the officer need to come from his office to a village or that when the farmland, inspect, and then give a fertilizer or the pest details, and the farmer will go to that place and purchase it and bring back, and then will apply for the entire farm. It is a very time consuming activities. Second thing is very expensive. The person has to come from that one is office to the farmland, and then he identified, and then he has to give a prescription. It is an financially is expensive. If we make the whole process an automated, then a farmer need not to depend upon anybody else. With an automated system itself, a farmer can easily get information about, so what is the disease currently the crop facing, and what fertilizer need to be applied, and what pests need to be applied to make the plant free from diseases. There is a need of automated a plant a disease a detection approach. So let us assume that there is a model which will be running. So where the model need to be run, because all the farmers need to access the trained model. So the model need to be available at the central place. If a model is available, farmer can send that one the input and get the prescription and as well as the disease details. So in order to deploy the model on the central server, and the model need to be trained, and particularly a deep learning model need to be trained. To train the model, deep learning model, first and the foremost is a data set is required, and that data set need to be labeled. To train the model and label the data set, agriculture expert is required. Agriculture experts will label the given data or the image of the plant or image of the leaf as this is 1 and this is 2 and this is 3 and this is 4 or healthy. First, the requirement is a data set creation. To create a data set, one need to go to the farmland, take the image of the plant leaf, collect it, then approach a scientist or agriculture scientist. Agriculture scientist will label that image as this is 1, this is 2, this is 3, this is 4, this is 5. Once the labeling is done, then use the deep learning model to train. Once the training is over, validate the detection ability of the model, and once it is achieved acceptable detection ability, then you deploy the model as a real world applications. This is very elementary stage. Then what are the challenges are involved in training the model? Why, if the matter is so simple, why people have not developed this kind of a model till so far? Developing a model for a plant desert detection, it is not so easy. Various technical challenges are involved. The first and the foremost is the structure of the leaves are different from a plant to a plant. And the model, one simple way is you deploy a different model for a different plants. Requirement is before uploading input image or the image captured by the farmer, a task is to label that one, the captured image as papaya plant or tomato plant or a cherry plant or paddy plant, like that. Then upload that one plant into a model, and model receive it. Then it will transfer to the appropriate a model, then process the input and give back the result. That's the one way. And it is a very impractical to train a single deep learning model for all different plants. There is a requirement, there is a difficulty of training a single deep learning model for varieties of a plant. That is one practical challenge. Second practical challenge is, if some of the plants will have a same symptom for disease as well as a deficiency, nutrition a deficiency. So it is a very challenging for a model to distinguish whether a given plant image is really suffering from a disease or a nutrition a deficiency. This is another challenging. Again, to distinguish, to train the model in order to distinguish between a nutrition deficiency and the disease, expert involvement is required during a labeling of a data. And the third, the technical difficulty is, so when we take an image of the plant, along with the image, the weed also is a part of the image. That when we send it on that image, whatever we extracted, we have captured it. If we train the model, which consists of a noisy data, that means the weed image, the model will not be able to learn properly. So there is a requirement to remove the noise before using that one, the captured image, to train the model. Take the image, then label with that scientist and remove the noise present in the image, then use that image to train the model. That's another technical difficulty. Another challenge is, whatever the mobile we are using it, the picture of an image, it depends upon the environment, and the clarity of the image will purely it depends on the environmental condition and the camera lens also. If a blurred image is captured, and the blurred image, if you're using to train the model, and the detection ability also will be a poor. And there's so many technical challenges are exist. So all those technical challenges need to be addressed. If we come to a deep learning model, so various models are already available, and if we choose any one model like a ResNet 50 or CNN model or the VG16 model, if you use any model, the inputs image size is already predefined. If we take a ResNet 50, input image size is a 224 cross a 224. Image a captured size in terms of a pixel is lesser than a predefined size, then a normalization of an image is required or the scaling operation is required. If a captured image size is a bigger than input image size of the deep learning model, then the scale down operation is required to bring that one the larger image into a predefined size. So during that one scale down operation of the image size or scale up of operation of the image size, a resolution of the image may be deteriorated, which causes a model for a misclassification. So this is another technical difficulties to train this deep learning based model for a plant asset detection. So in our work, because still my student is currently working on this, so that is the reason I'm not going to give a more details on this. It's a simple elementary information. Plant disease image, we have captured it, and then image resizing is required. Sorry. So image resizing is required because the deep learning model input image size is already predefined. So that is the reason a image resizer required. So objective of the image resizer is to the convert that one the input image size into a predefined image size which is required for a deep learning model. After that, the model will be a train. So once the model is a train, and for the train model, input the test images or real world images need to be supplied. So here in order to evaluate the performance of the train model, take the image and pre-process it, and during a pre-processing, a pre-processing task will be involved. Then you resize the image according to that one input size of the train model. Then that resized image you send it to a train model, and train model will give a information or will classify whether a given input image is a healthy input image or it is unhealthy input image. If it identified as unhealthy, in the sense given input image is determined or classified as a disease image, then that information will go to another database. That is a database consists of a prescription information, a disease, and for this disease, what is that one? The prescription. That means that one, what is the fertilizer and what is the pest. And before going to give a prescription about the disease, again a further level need to be required and further need to be ascertained. That is whether the identified disease is in the initial stage or it is in the moderate stage or it is in the severe stage. Again, based on that one, the severity of the disease, the prescription also will be suggested. So that is another component in the model. So these all the steps are involved, and okay. So this is the one we have captured the image in a real time. So many background images are exist, and all these background without suppressing the background information. If we send the image direct to the trained model, and classification output of the trained model will be a very poor, in the sense there will be a misclassification. So in order to remove the noise or the background noise, a background suppression operation is required. So that is done using a U square net architecture. So objective is to subtract the background. After subtracting the background noise, we'll get only that one the leaf image, and this leaf image you resize it and then you send it to a train model. Then train model will be able to accurately classify the thing. So this is the what. So we have done challenges which exist in this area. I explained, and next one is some of that one the elementary the information about that one plant disease detection I explained. So this is one active research area which is very much essential for tomorrow's world. So any questions on this? Okay, so no questions. Another that the 8 minutes of a time I have, so I will explain you another one more a real world. Uh, that another real world machine learning based or a deep learning based the project is lightweight phishing a website a detection for a mobile device. So phishing attack is one of that one the dangerous attack, and it is well known since a decade, and till today this phishing website is keeps happening it. The reason is that people are not aware about a phishing attack. So what is a phishing attack? It is not known to a school children's. Many of a school children's are not known, and many of illiterate people they do not know that one what is the phishing website, but still people are using that one the smartphone. So because of a lack of information about a phishing website, phishing attack, still a phishing attacks are keep happening it. So one way to mitigate or to reduce that when the phishing attack, so educate the people about a phishing attack and steps a need to follow to prevent a phishing attack. But it may not be a possible to train all the people in the country or the world. It is not possible to train all the people. So another way is to stop this phishing attack is moment whenever we are using whenever we are typing any any website name on the URL, there should be a message immediately. There should be a message to the user that the entered a website is a phishing website. Do not use it. So if such kind of an quick or rapid rapid a pop-up of message on a user device, then a certain degree of or certain quantity of a certain number of phishing attacks can be mitigated. So moment where a user is getting a message saying that when the entered website is phishing website, then people will not further explore the website. So that is a very much essential. So since this attack is a known attack, a various types of phishing detection technique or algorithm or approach already being used, but still, so there will not be any lightweight a phishing a website detector for a mobile device. So why this is a lightweight a phishing means amount of memory which is required to store on a resource constrained device should be a very less. Similarly, it should be a very rapid. As soon as a user enters that one website address on that one browser on user mobile, immediately message should be a pop-up. So it should be a fast. So the fastness it depends upon that one a number of computations are involved to detect and pop up a message. So here the detect means it cannot detect as it is. So it has to extract the feature from the entire URL, and those extracted feature and send it to the train model in a specified form, and the train model will check it, then will pop up the message. So whole this a process need to be fastened. It means a number of steps are involved to ascertain given a entered website is a phishing or not, it should be a very rapid. So that is why it is called as a lightweight a phishing a website a detection. So if tomorrow, if anybody has come up with a very lightweight phishing website, a detection model, that can be added as a plugin to that from the browser, and browser will it keeps searching the website entered by the user, extract the features and send it to the trained model, and trained model will give a pop-up message immediately so that a user can be prevented about a phishing attacks. This a phishing lightweight phishing website detection also involves a deep learning or a machine learning. A deep learning model is not advisable here. A reason is that a deep learning model needs a extensive computation power. So because of an extensive computation power, if we deploy it on the mobile, and battery may drain very quickly. So as a result, it is not advised to come up with a lightweight model using a deep learning model, rather than if a lightweight a phishing website detection model is come up with a machine learning based model, particularly for a smartphone, it will be useful for all users who are using a smartphone. It will be beneficial. So this is also a one of the real world application which is essential for today's and tomorrow also. Till that one phishing website phishing attacks are exist till that date, so there is a need of a rapid and accurate phishing a website a detection a detector is required, and it should be a lightweight. So that's all from my side. Last 2 minutes I'm having last 2 minutes I have a time to complete the thing. If anybody having any questions, please ask your questions. I'll clarify your doubts. Any questions? Audience side, any questions?
No, sir.
Okay. If no questions, then I'll say thanks. Thanks to all participants, and thanks for organizer to give this opportunity to share my a few words.
Thank you, sir. Thank you for your valuable information which you have been shared today. Thank you very much, sir.
Okay, thank you. Thank you.
Thank you, sir. Thank you very much, sir. Yeah, dear participants, we'll meet in the afternoon session by 2 o'clock sharp. You can leave the session. Thank you.